Okay, so once again you are mostly welcome. We are now in for our Wakisha item. Okay, so we are now still in for our Wakisha, not really Wakisha, but Aitel this time around. Our Aitel physics item 2, and please, it is going to be a massive one. By the way, you must keep on to it up to the end. We are dealing with our Aitel item 2. Please, you check in the playlist. We have Aitel mocks and have Wakisha mocks. Wakisha, it is for mathematics, and Aitel, we chose to at least have physics part of it such that we don't bore ourselves. We had enough of the math, then we're having more of physics. At least we go by balancing the boat a little bit. Alright, good. So in this item, by the way, it's a nice one. Like, why? Anyway, you should be knowing. You should be knowing. Why do? Okay, just imagine you have all ever gone in right? Maybe you know what you call that. Okay, maybe you go in the pub or a club, and then in there you find that there's a combination of colors. Of course, there's those bulbs which produce very many colors, green and so on. Why does the color of your cloth change? Anyway, that we're going to get the reasoning here. Then also, how do you think, by the way, how do you think the echo as a sound is important? Then of course, do you know how to do the echo calculations? That is about waves. If they give you something to do with echo, a calculation in echoes, remember we said that echo is the reflected sound, but do you really know how we do the calculations about echoes? Okay, just keep yourself here such that you don't really miss out. And without wasting time, let's get to the point. Alright, simply we call for your subscription. Please remember to subscribe. Okay, don't forget to share, like, and also alright, comment. That will carry some bit of sense. Okay, now please maybe before we proceed, a simple reminder, on the channel we have a lot more as far as items are concerned. We have items of physics, we have items of math, we have items of chemistry. Please consider visiting the playlist and watch video one by one. Please, the more videos you watch, if you're a student for example, you may find that accidentally you may land on some 4 items in a paper, and guess what, 4 items are enough for you to have your A. Of course, the ones which are done in a paper. So just keep to a video, keep watching. You realize that you will not be disappointed as far as you know busy concerned. Of course, they will not bring something really which is here, but maybe they can bring a resemblance. Of course, you realize that now physics playlist we have over 16 videos. Okay, and of course it is impossible. If you watch at least some of those videos there, you realize that you'll find at least 1 or 2 of the items, or even 4. Okay, so with that, or without wasting time, let's get the question. We read it, analyze, and we see the way forward. So there we are. They're saying, okay, let's get our laser pen. Okay, so they're saying a man attended a live concert of his favorite band at a large outdoor venue, which was near from the tall building. He noticed sound of the band returning from the building. Of course, that returning sound you all know is an echo, returning from the building, and heard it after 6 seconds. Okay, that's the time when the original is produced. So you know that the time taken for the sound to move from the band to the building back to the man takes 6 seconds anyway. So they say, as the sun sets, all right, the stage lights, of course, sun setting means that is the evening, as you are going to the night hours, which will be dark. Of course, the stage lights light up with vibrant colors, and the stage becomes the center of attention. Of course, when you're in a concert, of course, you must all look at the stage and see what is coming on next. All right, good. Now they're saying the heavy bassline begins to thump through the speakers, resonating throughout his body. Okay, I hope some good vibe there. The singer's powerful voices fills the air as the crowd erupts with excitement. Of course, if a favorite musician comes in front there, or maybe on the stage, no one can just remain in the seat. and that's what is happening here. However, now in the physics we don't take that. So as he decided to enclose the stage, now here okay, to enclose they're like meaning, anyway, it doesn't really reason out here, but to enclose they're like meaning to move near the stage. Okay, to enclose the stage, his color of the clothing changed. Oh, that's a bit magical. Then hint, the thing, the stage was illuminated with blue, green and red lights. Okay, the man was wearing, okay, now look, the stage was illuminated. Illuminated means, to illuminate means to produce light, so it means that the stage was producing light with the blue, green and red lights. Okay, the man was wearing a yellow t-shirt, a yellow shirt with blue stripes, a yellow shirt with blue stripes and cyan trouser. Some people read it as cyan, but it's cyan trouser. Okay, good. That's where I need to be. Speed of sound in air is 320 meters per second. Let's get there still. So they're saying again that as a learner of physics, help the man to, part A, determine the distance from the band to the tall building. All right, good. Then understand. Okay, understand why the color of his clothing changed. Okay, that's a bit good. And by the way, this part B is where it is a bit sensitive. You need to really know much about that. Okay, part C, prepare a write-up about applications of reflection of sound to the community. In fact, these are like asking the applications of echoes in real life or in the community. Okay, good. Now with this, you're going to start off with this. Determine the distance from the band to the tall building. That's where we're going to start off from. Okay, good. Now with this, let's get here. I think, get some ink. What know the distance? Now what you should know is that we shall now say, okay, in simple terms, we shall say that our building is right there. This is our building. Right there is our building. Now, maybe from here to that, okay, now where the man is, like this, where the man is, remember the sound is coming from the stage, and I think this is where our stage is. Maybe this is our stage. Now when the sound comes, the sound bypasses the man. We count from here. The sound moves like that, in that order, and again the sound. Now remember, the distance from here to here, the sound moves a distance d towards that, and again the sound comes back like this, again covering another distance d, meaning that in what time, but the time taken for that to happen is 60 seconds. Now you see, now what will be the total distance here? You find that the total distance in that context will be equal to, you add dcd plus dcd, the d when going this side and the distance when coming back, in order to give us an echo. So the distance is same as 2d, like that. But then what was the time taken? The time taken was 60 seconds. I hope you can really see there. Then somewhere here they've given us that, but of course as sound is moving in air, sound moves at a speed of 320 meters per second. Okay, good. Now the velocity v is equal to 320 meters per second right there. So it means that in here we have the velocity. Look here, we have our velocity, we have our time, we have our distance d. But distance is covered as 2d, but they want the value of what? D. How are we going to really get there? Now you all know that from this acronym here, okay, this is like, this one is not a bit vibrant. So from this acronym of this, okay, like this, we have this. So you have this acronym here of D, S, and then T. Now what does it mean? It means that speed S is equal to the distance over time. Okay, if you can really see that. But then this speed you're seeing here, the speed will be the same as our velocity, like that. The distance will be the same as our d, the time will be the same as our small t, like we have them here, right there, and there. Now, so our velocity v in the name of speed is equal to the distance 2d over the time taken. Of course, this is the formula we use for finding calculations to do with the echo. Why 2d? I've explained how that comes about. So by the speed is 320 equals to 2d, the distance we want to find, over the time, which is 6 seconds. You calculate this and you get the value of d. With that, you will have gotten the answer. Without wasting time, let's go and see how part A is answered right away. Let's see. So first of all, we're saying that since the man had a returning sound, there was an echo. Okay, meaning the sound travels to the surface and back. The total distance is twice the distance between the source and the surface, 2D. I've explained how that comes about, not bother. Okay, now a summary we have, but V will be the same as a speed of sound in air, D will be the same as distance, and T will be equal to the time. Then also we know that our speed V was that, and our T was that, and our distance, we don't know it really. Of course, you remember that in the question we had this. Now in the question we had this guy 320 meters per second, we had the time taken, and what the D. But of course, you all know the formula that from V is equal to 2D over T. Now we substitute, we have the V there, we have the T right there, we can now get the D. Let's substitute in simple terms. Okay, now when you substitute, you realize that you shall get 320, of course, the V right there, the T was 6, we have it right there. Now we want to get the value of D. What you're going to do, you're going to multiply both sides by 6, and that shall have, okay, you see that this 6 dies out with this, then you multiply a 320 by 6. With that you get a 2D is equal to, multiply 320 by 6, you get a 1920. So we need to now divide. Dividing, what are we going to do? We want to get the value of D, dividing both sides by D. Let me resolve this, some people is complaining. Okay, now we have a 2D dividing both sides by 2, like just you can have here, right here, like this. We're dividing both sides by 2, this 2 will go with that, and this 2 will divide this to give us that very value. You see, D is equal to a 960 meters. Of course, the distance between the man and the, okay, they wanted the distance between the band and the tall building, the band and the tall building, the band and the tall building, like that. So of course, now maybe if I to make clarification, you see, this is the stage, and the tall building is here. Remember, at first the man had moved near the stage, so mean that where the stage is, the man is right just here. So the sound goes to, that is the distance D, and again the sound comes back like that, that's another distance D. So when you add these two, you get to D. I explained that earlier on. Alright, good. Now with that, it is 960 meters, that's the distance. So let's see how we can summarize that. Conclusively, we shall say the distance from the band to the building is 960 meters in simple terms, and that gets part A of our question perfectly answered without fail. Okay, let's continue. We move part B. What are they saying? Determine the distance from the band, part B, okay, understand why. Okay, help the learner, if you're as a learner of physics, help the man to understand why the color of his clothing changed. Okay, remember this man had a cloth of this type. A cloth which was yellow but with blue stripes. Hope you don't really forget that. Let's go back and refer to that in the question. So this man was putting on what? So the stage was having these lights here. Don't forget, the stage was having blue, green, and red light. Those are lights being produced. Of course, you ever seen on the stage, the other ones are like bulbs which always illuminate the stage to decorate it with some different colors. You find that they give very bright light but of different colors. So that is it. Now we want to see what was the man putting on. The man was wearing a yellow shirt. You see that? The man was wearing a yellow shirt with blue stripes. Now to call stripes are, maybe I'll just get a sketch of what a shirt is. Like this maybe. Sketch of what a shirt is. Like this. Okay, like this. Now, the stripes are those small lines which you all know. Those stripes there. The line is in there. That is his shirt. So that's how the shirt looks like. But just guess that the stripes are blue in color, meanwhile the shirt itself is yellow. Take note of that. Okay, good. Now, with that, let's first of all go and understand something about colors. In order to come up with this explanation in the best way, allow me to take you through this first of all. And now the story begins here. The story begins from here. Please, you have to understand this area such that you can be able to answer the other part. Now, the story begins with what we call an electromagnetic spectrum, which has a lot of things. We have got the radio waves, the microwaves, we have the infrared, we have the visible. Now, this visible spectrum is this part here, right here. Visible spectrum is this. The infrared is this. You cut off from here, like that. The microwaves are just right here. Then the radio waves are just right here. So, but our point of interest is on this visible spectrum. Visible means that it can easily be seen. Now, what you're seeing here is what you're defining for you, zoomed for you here. Now, the visible spectrum form what we call the Roy-Gibbs colors. The Roy-Gibbs colors, whereby this visible spectrum has the Roy-Gibbs colors. Please, the color changes about clothes. Why does the cloth appear dark? Why does the cloth appear white? We are getting everything covered right here. So, now, if we're trying to zoom, what does Roy-Gibbs mean? Roy-Gibbs means that we have red, orange, yellow, green, blue, indigo, violet. Now, these are the colors we have. Okay, now, as far as the visible spectrum is concerned, that aside, we know that when light, of course, light is always incident on our clothes, and that's how we are able to see that green light, that yellow light, that red light. Okay, now, as light, what you must know is that there are two things. We have what we call reflection. Okay, now, incident ray is here, and the reflected ray is here. But at a point of incidence here, two things happen. At a point of incidence, two things happen in simple terms. And of course, not far from you, just guess. What happens here is that we get, first of all, we get to know that there is some bit of, okay, there is some bit of reflection and there is some bit of absorption. Absorption. I hope you can really see that. Now, if we see, if it is reflected or absorbed, if it is absorbed, now what you should know is that what you see, the color you see, comes as a result of reflection and absorption of some colors. But just know that what comes as a ray of light you're seeing there is a combination of these Roy-Gibbs colors, all of them. But guess what? You just end up seeing a cloth as just yellow. What really brings that? It's because you are able to see yellow because yellow has come as a result of what? Reflection. Yellow has come as a result of reflection. Then the remaining colors have been absorbed. I hope now we can really start reasoning here. So it's all about absorb the rest, reflect one, then after that color comes on there. So now that's what you have here. Now when you have, okay, after reflection, now guess if a ray of light comes in this way. These are the Roy-Gibbs, of course. You see the color changes, just like a rainbow. Once this ray is incident here, you find that this surface here may absorb. So only certain colors are absorbed. So you find that this surface may absorb all the other colors and reflects what? And reflects red. And that's why with your eye here, for you will be able to see a red color. Yet in actual sense, a combination of colors came. The colors which you don't see, like if you see red, just know orange, yellow, green, blue, indigo, violet have been absorbed into the body and cannot be seen. And why are you seeing red? Is because it is red being reflected. There are two things, reflection and absorption. Hope you really come to understand that. So as this one is incident here, guess what? As this incident here, in the next context, you see that someone will be able to see some blue light. Now as you see blue, just know the rest have been absorbed and only blue is being reflected. So some colors are reflected, some colors are absorbed. Hope you can really see this. That's where our rotation is. Now still again, okay, we get to this. Now on this level, what does it mean? We want to see why is it that for you when you are seeing or looking at a leaf, you really see that it's green. Anyway, what really brings that? But then not far from what you know, we have got what we call a reflection and we have what we call absorption. Now a reflection is what you see. A reflection is what you see, is a reflection. Then what you don't see, is absorption. The one which has been absorbed is what you don't see. So what you see is the reflection, what you don't see is the absorption. Now look, what are we seeing? We are seeing green. It means that now here all the rays come, the Roy-Gibbs colors come and they're incident on that leaf. Just know the leaf is not green as that, no, but the leaves are green because they reflect green color. Are you now seeing that? Okay, now since they reflect green color, just know that from the Roy-Gibbs, all other colors have been what? Absorbed. So with your eye here, for you to get an impression of green color, just because from this one which was incident, it was only green color which was reflected, and therefore you will see a leaf as if it is green. So leaves are green because they reflect green light. You really see that. Then on the context, what if when we want to know, what if when all light which has come, this one here, what if when all light has been absorbed? Or we are asking, what if when there is no light reflected? What if when there is no light reflected? What does it mean? If all light is absorbed, then the object will appear dark. So that black cloth you see is because that all light has been absorbed. In fact, what you are meaning here is that all the Roig colors have been all absorbed. Therefore, what we'll have is a black color impression. So objects that absorb all visible light will appear black. I am saying that. I hope you really see that. Once you say black color, all light have been absorbed. Once you see green color has been reflected, the rest have been absorbed. Once you see red has been reflected, and the rest have been successfully absorbed. Hope you really okay. Understand that. Now, what if when? Okay, on the contrary, here we absorbed, all light was absorbed. What if when all light is reflected? We are saying objects that reflect all visible light, meaning what if when all the Roig colors have been reflected? In fact, here it means that no light has been absorbed. You will see this kind of impression. This water here acts like that, the way mirror does. You really see that what you have up here is what you have down this side. That's how what happens when, okay, all light has been successfully reflected and none is absorbed. So you really see the real impression. You see this building looks like the one under just right here in the water. Of course, we have talked about black color. Don't you think we have white? Guess where it comes from? Now it introduces what we call refraction. Simply, refraction is the bending of light rays when they're moving from a more optically dense medium to a less optically. In fact, when it is the bending of light rays when they are moving from a less optically dense medium to a more optically dense medium. Now look, this one here is our prism. You all know what a prism is. Please, if you don't know what a prism is, go and check in the playlist. We have the UNEB paper of last year, UNEB marking guide. You still have more about a prism. You go there and watch it. Now, what you're seeing here is white light. Now, an experiment was made, and realized that when the white light is incident on a prism, the Roig colors are produced this side. The Roig colors are produced this side. Then they said still, if the Roig colors are reflected backward, like this, they will form what we call white light. It means that when you get all the Roig colors and mix them in one container, maybe it is paint, what you'll have will be white light anyway. So all the colors should combine to give white light. So when all colors combine, they give us white light. Seven. Alright, good. So now let's continue. So I've already explained what that really means, and of course, please, this is the most interesting part, in fact the one we really needed, so that we get this done. Okay, now since you have understood all that, just know that for a color to be seen, then that light must be reflected. Then for you, the colors you don't see, it means that they have been successfully absorbed. So as far as color changes are concerned due to clothes someone puts on, they are specifically based on color absorption and color reflection. As simple as that. Now let's go to this, the last part of it, then we go and start answering everything. Now, the colors which the eyes have got a sensitivity on only 3 colors, that is red, green, and blue. Our eyes are only sensitive to these 3 colors here. But of course, guess what happens? If you have red, the additive primary colors, when you have red, green, and blue, what really happens? What if when you combine these guys? Just imagine if we combine these guys here, and now they're giving us here some intersection of those circles here. Just know that what happens here really. Now when you have, remember, we have here blue, we have here green, we have here red. Now a combination of red, blue, and green gives us other interesting stuffs. Now guess what? Here, this one here, cyan. We have this one here is cyan. Cyan is a combination of blue plus green. One would wonder how I'm getting that. You only get this naming on this line. We have green. That's why I have green. That. Then here, this line I have this side is blue. So to get cyan, you add blue plus green. Hope you really see that. Then to get magenta. How do we get magenta? Now this side says what? It is blue plus Okay, this one is what? Red. So blue plus red gives us magenta. How about yellow? Yellow have this side is what? Red. So yellow you add red plus plus green. Hope you can really see that. Why? We have green this side. So yellow is red plus green. Cyan is blue plus green. Magenta is, oh, now one would ask, is it why? Okay, it's not all that hard to draw. You can just write like this. Just the Venn diagrams you draw in mathematics, like that. Then midway you can now put, this is your blue, this is your, okay, red, this is your green, like that. Then you to start putting in red plus green, that is yellow. Okay, blue plus green, that is cyan, C. Then red plus blue, that is magenta. Then these three here combined is all the colors, like what I'm meaning, the blue, the green, and the red. Once you have more than 3 colors, then we have white light. Hope you can really understand that. Now, of course, on the contrary, let's see this. This is where the most interesting part is, and of course, the learning point of this whole question here, or item, so that we get it done. Now, what you must know is that if, say for example, we have yellow, I will explain here. Say for example, we have, okay, maybe you have a yellow cloth. We have yellow, but inside yellow has what? Yellow has red plus green. Now that's what we have. And say for example, a red light comes. If the light coming, okay, I want to explain this such that we can go and get this answered. Okay, if the light coming is red, but also in part of the components of yellow is red, then here we're going to reflect what? Red. Do you see that? Then that cloth will appear what? Red. But what if when we have yellow light again, yellow, whose combination is red plus green, but again this time round we are bringing what? We are bringing blue. Blue color is then coming. Once blue color is coming, just know that this blue here is not having any common color with the cloth where this blue color is coming. So the yellow cloth, which is a combination of red and green, will not reflect any light. Therefore, it will appear black in color or dark. I hope that really makes some sense. Let's get the answers and we get this done. Okay, let's get there. So we see. Now the answer in part B, why do clothes appear different? Remember, maybe just to remind you a little bit here is that, let me just do for you our shirt here. Remember our shirt was this. This is our shirt. This is our shirt. Please remember our shirt was yellow, like that. Allow me just use that sketch. Then the other color was what? Blue. The stripes were blue in color. That's how our shirt maybe looks like. That code. Hope this will help us. That's the kind of illusion you must be seeing right here. Okay, now let's get this written. Okay, but remember the clothes was yellow, so what happens is we must see, and what you must know is that on this yellow color we having very many colors coming on. We have got the red from the stage, we have got the green from the stage, and we have got the blue from the stage. All these colors here are incident. All these colors here are incident there. All these colors here are incident onto that. But of course, don't forget. Let's get this explained quickly as early as possible, such that we can get there. Now we're going to talk about one color at a time. Now to begin the story, we are beginning with when blue light comes. When blue light comes, what really happens? What really happens? Now remember, this man here is putting on a cyan trouser, but a cyan trouser contains what? Okay, now let's get here. So they're saying when blue light shines on his clothing, when blue light shines on his clothing, remember the clothing is we start with the yellow shirt, but of course when you see yellow, I want to explain this. When you see yellow in the bracket, think about red plus green. I've already clarified it for you here. Red plus green. Now who is coming? It is blue coming. So blue is the one coming. Now if blue is coming, does blue have any similarity with these people here? No similarity. So therefore there, the cloth will appear black. Why? All it has been absorbed. It doesn't have a similar color. Once they have something similar, then that blue color will be reflected, but we don't have that. So the cloth will appear dark. Now, but remember in here about our shirt, the shirt has, remember the shirt is yellow, but now we have blue what? Blue stripes. Blue strips. Blue strips, those are the lines which are on that cloth. You all know what a strip is. Now, or stripes. Now here what happens is Remember, blue color is coming, and that blue color is incident on the blue strips. If you get blue coming on blue, we reflect the blue. Therefore, with blue stripes, because the cloth will appear blue, because blue light is absorbed into the yellow object. Now here they're explaining why the cloth has appeared darker. But why has the blue stripes appeared blue? Is because the blue has reflected the blue back to the eyes. Now remember, this person has a cyan trouser also. Now, but a cyan trouser, cyan has a combination of green plus blue, like that. Now a cyan trouser like this, but remember there is some blue light coming. Remember the stage had 3 colors: red, green, and blue. We are starting with 1, so we have started with blue color first of all. It's magic on all these 2 things: a yellow cloth with the blue stripes and a cyan trouser. Now cyan has green and blue, but remember blue is coming. When blue meets blue, reflects blue. Therefore, the cyan trouser will appear blue because the cyan trouser transmits only green. It means that the green which you have not seen has been absorbed. And there we use the word transmit. Absorbed or transmits only green. Transmits only green, absorbs only green and blue, and absorbs all the other color, meaning that the other colors are absorbed including green, and then we shall have just a blue color reflected right. Okay, there. So let's get there. Now this time around, let's talk about another color. So what if when the green color comes in? Remember the stage had 3 colors. A stage had a blue color, a green color, and a red color. So we have finished the blue. Let's go to green. All right, now what you must know here is that all right, good. Okay, let's get this explained. Remember again, I'll remind you that now, remember, have our cloth, and now this time around here we're having green coming. Green is coming where? On our yellow color, and this, when it's coming on the yellow color, also we have got the blue. We have got the blue stripes. Then also we have got what we call the cyan trouser. We have what we call the cyan trouser. But of course, yellow has what? Yellow has red and green by nature. And now the blue stripes have only blue. Good. And then the cyan has the green and the blue colors. Now let's see who is coming. The color which is coming is green. Allow me use green ink itself. So if green is coming onto yellow, now green will find another green here, and therefore we are going to reflect out what? Green color. And that's why I'm saying that when green light falls on the clothing, the yellow shirt with the blue stripes will appear green because you have reflected green. Now let's explain the blue stripes. The blue stripes, and you are bringing green. What happens? If you are bringing green on blue, there is no matching. Therefore, that cloth will appear, that part, the blue stripes will appear what? Black. So therefore, with black stripes, hope you can really see that. This is because yellow transmits only green and red. While green light is absorbed in the blue stripes. Hope you can really see that. Therefore, now, what about the cyan trouser? Remember, so now our cyan trouser, okay. Now our cyan trouser, let's get this compared. First of all, let's get this compared. Now our cyan trouser, remember, I'll use green again. Our cyan trouser, remember, we are using green again. So when green is coming onto cyan, but remember cyan, now I don't know how you pronounce that. I don't know. Yeah, I prefer calling it cyan, but it's cyan, whatever it is. Now remember, green is coming, but we have another green. So we have green, then we shall reflect green. Okay, now that's why they say that the cyan trouser will appear green. Why? It has absorbed all other colors and it only reflects green. Now remember, we have very many colors, but I guess you now know what to do. Like we had green. Remember, we have talked about blue. We have talked about green color from the stage. Now let's talk about the red color from the stage. Okay, now the red color still again I'll repeat. The red color here, the red color coming. Remember again, I'll repeat. I have my yellow already waiting, but yellow is what? Is red plus green. So if you have this, and again it is red which is coming there, red. Once you have red, then we reflected red. So here a red color will be reflected. You see that? But again on the blue stripes, remember they are blue. Once you bring red, the blue stripes will appear dark. What about on cyan? Remember cyan is green plus blue, but we are bringing red. No common color there, so it will appear dark. Once there's no color in common, then dark, it appears dark. So when red light falls on him, the yellow shirt with the blue stripes will appear red, okay, because red is been reflected, with the blacker stripes, and the cyan trouser will appear black. Where you see black, all colors have no color in common. Where you see a color, it means when you see red color, then it means that red was common in both categories. And that gets that part there correctly and perfectly answered. So without wasting time, let's go and look at part C. Look at part C and we call it off. So part C, they're saying here, get a pen. They're saying, prepare a write-up about applications of reflection of sound to the community. So here they want the applications of what an echo. Wow, how are echoes useful? In which way and where? Anyway, let's get that here. So now we will get to know that. Now, of course, when they say write-up, doesn't mean that you should write a story. Because I know some people, once they say for a write-up, they are ready to now start writing, my name is that, I come from this. You see, anyway, yeah, it is not really meant to be that. And please, in an exam, you're not allowed to use bullets. I only use them here to show you that is a point, another point, another point. So for you, in exams, don't always use bullets. So reflected sound, which is echo, is applicable in the following ways. Okay. Now, what you should know is that the bats and dolphins use the echo to navigate and locate prey. Yeah, you all know about that. That bats don't have eyes, so they use the echo to know that there is a building and they will turn. Like, so for example, you can have a building here and maybe you have a bat coming. Once it comes, it sends an echo, it sends a sound, and that sound comes back as an echo. Once the echo comes, the magnitude of the echo tells the bat which kind of obstacle is there. So therefore the bat will have to dodge away at a very fast speed. Just know that one happens in just a millisecond. Of course, someone will say, when will the sound go and when will the sound come back? It happens in a millisecond and that will be done. So that's one way we can get the echo into application. So used in submarines and boats to detect underground objects. Yes, you all know the submarines use echoes. They send, like, say, if this is our water body and the submarine is within there. Now, as it is moving, it will send a certain sound, and if there is a stone here, that sound will come back, be sensed by the digital machine, and then they will have to turn or move away from that point. Now, we have used in the study of seismic waves and earthquakes. Now, you all know what an earthquake is. Assuming this is our building, yeah, like this. When the earthquake comes, we'll make this building to be unstable. Now, that shaking of the building, okay, that shaking, we call it a seismic wave. That kind of shaking, yeah, like the way you're seeing. In fact, let me put for you this now. That kind of like shaking. That shaking is what we call a seismic. Seismic makes objects to shake, in fact, and the seismic waves can make cracks into the soil surface. Anyway, hope that really makes some sense. Let's get this done very fast. So now, used in ultra scanning and medical imaging. Of course, you all know that when they ultra scanning, especially pregnant ladies, how they know that maybe the baby is dead or the baby is still alive? They'll put there and listen. Of course, there's always some sound made by the baby inside the womb. It's a bit of science, explained more in the biology. So I'll just end on that. Then, used in studios and concert halls to improve sound. Yes, echoes are used. Like for some of you who watch some VJs who watch movies, yeah, there's that one VJ who uses that echo there. You will know about that. Okay. Now, used in speaker placement to ensure clear sound. Yeah. Now, here, the echoes are used when they're putting the speakers. Say, for example, like this. speakers placement. Okay, there may be, for example, play. Of course, you know what a bass is. You ever been on a function and you really find that you are very far from the place, and as this speaker produces sound, it acts more like it is reflected back in that way. So they can really know that now this one is a bass, this one here is alto, this one here is tenor, and so on. With that, we kindly end this question right. Thank you for watching. Thank you for watching. I'm really grateful for the great works you are doing, and that's for you again. See you later. Let's meet right there.